This is chapter 6, quantum mechanical model of an atom, homework number 6. Choose the boundary surface that corresponds with a dxz orbital. So basically it asks you, which one, judging from the different shapes and in the three-dimensional orientation, so then which would represent a dxz orbital, okay? So we already learned, so for d, there should be 5 d orbitals. So we have 4 here, we have another 1. So, but the choice, the correct answer is not this one. So therefore, it's enough for us to just look at this 4 here. Okay. So dxz, let's just take a look. Okay. So of all of the 4. Start with the first one. You see the first one, those orbitals, those or you can call those loops. So if you try to find an x, then that's the z-axis, you see? So the x of this shape is a z. So therefore we call that dz squared. And now this one, if you look at that, you see those 4 lobes, basically, all right? So there's one on the negative side of y, another one on the positive side of the y. Again, you see? So that, no, actually both are negative side of the y, and that's the positive side of the y. Okay? And then for x, so there are also 2, 1, 2 on the negative side of the x, and then 1, 2 on the positive side of the x. So therefore, this just involved in the xy plane. You see the z, you don't find any electrons. Why do I say you don't find any electrons? Because electrons will move along its orbital. There's no orbital right there. So therefore, z-axis, that direction, there's no orbital. So what you can determine now here is that's just dxy. Okay? So now look at this one. This one, there's nothing along the x-axis, all right? If you look at the electron density or the orbital, nothing along the x-axis. So therefore, it has to be yz plane, all right? Y and z plane. So therefore, that's called a dyz. And here, there's nothing, okay, along the y-axis. So there should be normally, there should be no electrons be found right there. So therefore, this one is on the z and x plane, all right? So 2 on the negative side of z, this one and this one. You see that's on the negative side of the z. And this one and this one, these 2 are on the positive side of the z. All right? And then x, these 2, 1, 2, these 2 on the positive side of x. And these 2 on the negative side of the x. All right? So therefore, this one should be dxz. They ask us which one is dxz. That should be this guy right here. Okay, that's question number 6.